students, today we are going to study electric field intensity. So the questions what they may ask in this is define electric field intensity, explain the electric field intensity at a point due to point charge, and show that the electric field intensity at a point due to n number of point charge is given by this formula, that is E is equal to 1 by 4 pi epsilon naught summation of I is equal to 1 to n qi divided by Ri square, okay, into AR. So what is this electric field intensity? In simple words, electric field intensity is nothing but the force at an unit charge. Okay, so if we consider a force in Coulomb's law, we have studied the force between two charges is given by the formula F is equal to Q1 Q2 divided by 4 pi epsilon naught into AR. In that force equation, if we consider one charge as our test charge, that is one Coulomb charge, test charge, then the whatever the force exerted at that 1 Coulomb charge we call by the name as electric field intensity due to the another charge present. Okay, so now let us come to the definition. So before going for the definition, here we are considering one charge fixed at one position in a position. So let the charge name as Q1, and we are moving another charge slowly, a second charge slowly around it. We note that there is a force exists on the second charge everywhere, okay, wherever we are moving. The force exists on this test charge is given by the formula due to Q1 is given by the formula Ft is equal to Q1 Qt divided by 4 pi epsilon into R1t whole square into A of t. Here 4 pi epsilon naught, you know, it is a constant. Q1 and Qt, Q1 indicate the charge at which whose intensity we have to measure, and Qt is the test charge, and R indicate the distance between the charge and the point where we are measuring the intensity, okay, and AR indicate the unit vector of this directional vector. So there is a directional vector between your Q and what we call direction or distance vector. There is a distance between Q1 and the test charge. So this directional or distance vector has an unit vector, and it is given by this formula. In another words, this is the unit vector which indicate the direction of my force. Okay, so rewriting this one, it is given by Ft divided by Qt is equal to Q1 divided by 4 pi epsilon naught R of it, etc. Okay, here this Ft by Q we call by another word called electric field intensity. This force per unit charge described a vector and is called the electric field intensity. Okay, in another words, if I take Qt is equal to 1, then Ft is nothing but our electric field intensity. So electric field intensity is nothing but a force per unit charge at some point where we are measuring it. So E is given by Q1 divided by 4 pi epsilon naught into R square into A. So R indicate the distance between charge Q1 to the point where the test charge is present, and this P indicate the position. Okay, so in general way we can write it as E is equal to Q divided by 4 pi epsilon naught R square into AR. So as I told before, AR indicate the direction of our electric field intensity. Okay, R is the magnitude of the vector, or it is the directed line segment from point at which the point charge Q is located to the point at which E is desired. In simple words, it is the distance between your Q1 and the point where you are measuring. Okay, and AR indicate the direction. So now we will go for a derivation what they have asked. If there are n number of charges and we want to find the electric field intensity at a point due to this n number of charges, then we can calculate like this. Consider n charges Q1, Q2, Q3, etc. as shown in the figure. The combined electric field due to n number of charges is the vector sum of electric field intensity exerted by each charge at point P. The distance of point P from Q1, Q2, Q3 are R1, R2 and Rn respectively. Then the unit vectors along these directions are AR1, AR2, etc., then this can be written as E is equal to E1 plus E2 plus E3, etc., up to En. In another words, I can tell that the electric field intensity due to combination of charges is nothing but the sum of the electric field intensity due to the individual charges. Means sum of all the electric field intensity, if we add them, so we will get the combined electric field intensity. So here we know the formula of E1 as Q1 divided by 4 pi epsilon naught R1 square into AR1, E2 as Q2 divided by 4 pi epsilon naught into R2 square into AR2, etc. So if here we can take 1 by 4 pi epsilon naught as common, remaining terms we can write like this, Q1 by R1 square, etc. So this summation, this one can be written as a formula E is equal to 1 by 4 pi epsilon naught. Here this sum Q1 by R1 plus Q2 by R2 square plus Q3 by R3 square, etc., can be written in general as summation of I is equal to 1 to n Qi divided by Ri square into AR vector. Okay, here AR vector indicate the unit vector in the of your electric field intensity of the particular field. Okay, so RP indicate the position vector. You know how to calculate the unit vector. Okay, so in problem we will see it. Here let a point charge Q1 is equal to 25 nanocoulomb located at value A is equal to. So here A, B, C indicate the point where our charges are present. So at point A charge of 25 nanocoulomb is present. At point B, this 60 nanocoulomb is present. At point C, we have to measure the electric field intensity. Okay, so first we have to calculate the position vectors of each point. The position vector of C is given by this value. Here C is present at 1, 2, 3, 1, 2, 3, means at 1 in x direction, 2 in y direction, and 3 in z direction. So the position vector can be written as 1ax plus 2ay plus 3az. Similarly, for A, we can write the position vector as 4ax plus minus 2ay plus 7az, minus 3ax plus 4ay minus 2az for your position vector for B. Now we have to calculate the distance vector between C and A, distance vector between C and B. Okay, so distance vector between C and A can be calculated as RC minus RA. We know the value of RC and RA. After subtracting, we will get the value of RCA. This is the value of RCA. This is a vector what we obtained, directional vector we obtained between C and A. And the magnitude of this directional vector can be written as square root of 3 square plus 4 square plus 4 square. We have to take only magnitude. We have to neglect the signs here. So the total value is square root of 41. Similarly, a directional vector for RCB, that is RC minus RB, can be given like this, and the magnitude of that RCB can be written like this. Okay, and it is equal to square root of 45. So now we will put these values in a formula. The total electric field intensity E is obtained by due to two charges QA and QB is given by the electric field intensity of A due to A plus the electric field intensity due to B. So electric field intensity due to A is given by QA divided by 4 pi epsilon naught distance vector square into n unit vector. Similarly, the value for your B, electric field intensity for B, is given by QB divided by these things. After this, we will substitute the values. This unit vector can be, this ACA can be written as the distance vector RCA divided by magnitude of the distance vector. Okay, so here ACB can be written as distance vector RCB divided by the magnitude of the distance vector. Okay, so after substituting these values, we get a final value like this, and then after substituting this RCA and RCB, we got an value like this. After doing some mathematics, we will get this value. So the unit, the direction of E is obtained by the value of E divided by magnitude of E. The value of E or the vector E divided by the magnitude of E. What is magnitude of E? Magnitude of E can be calculated by square root of 4.58 square plus 0.149 square plus 5.516 whole square. Okay, we'll go for another question. So find the electric field intensity at a point 1, 1, 1 caused by four identical 3 nanocoulomb charges located at the position P1, P2, P3 and P4. They have given the position where P1 is there, P2 is there, P3 and P4 is there. So there are four charges, and due to these four charges, what is the total electric field intensity we are obtaining, that can be calculated here. Okay, so first we will calculate the what we call position vectors. Position vectors of point P is given by ax, 1ax plus 1ay plus 1az. Position vector of point P1 is given by 1ax plus 1ay plus 0az. Okay, position vector of R2 can be calculated by minus 1ax plus ay plus 0az, like that. Okay, position vector of R1, R2, R3 and R4 point P1, P2, P3 and P4 are calculated. After calculating this, we have to calculate the distance vector. Distance vector between P and R1, it is Rp minus R1, and the magnitude is also calculated. Similarly, distance between your P and R2, distance between P and R3, distance between P and R4. So we have calculated the vector as well as their magnitude. So after calculating, we know the formula. Okay, total electric field intensity is given by the sum of the electric field intensities obtained by each individual charges. So electric field intensity due to Q1, Q2, Q3 and Q4. So now Q1, Q2, Q3 and Q4 all are same as per the question. It is 3 nanocoulomb, and 4 pi epsilon naught is also same. Have taken 4 pi epsilon naught separately. Then the remaining terms are AP1 divided by RP square, AP2 divided by RP whole square, AP3 is here AP1, AP2, AP3. It indicates the unit vectors of P1, unit vectors of electric field in P2 due to charge 2, charge 3 and charge 4 in P1 direction, P2 direction, P3 direction, P4 direction. Okay, so just we have substitute the value. We know that 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9, and this 3 nanocoulomb is 3 into 10 to the power of minus 9. So after substituting these values, we got like this. Here AP1 can be written as Rp divided by magnitude of Rp, AP2 can be written as Rp2 divided by magnitude of Rp2, and Rp3 divided by magnitude of Rp3, like this. Okay, and after substituting the values, we got this answer. Hope you understood. If you don't get these things, once again I repeat after in the offline class.